But there is a class of problems where time periods are long, complexity and uncertainty are high, and the consequences of error are substantial. The case of protecting Pacific salmon that we have looked at in previous chapters is a good example. Outcomes for salmon depend on many variables, including inherently uncertain ones like climate change. Species success plays out over decades rather than months, and the consequences of bad outcomes are broadly felt in human incomes and ecosystem losses. We believe the 7 steps model is useful for complex problems with high uncertainty, particularly the emphasis on an iterative approach, but we will add some frameworks to our problem-solving kit to manage these more difficult, long-term problems, some of which involve putting the analytic tools of Chapter 6 into practice. In this chapter, we define levels of uncertainty and the implications for problem-solving. We provide a problem-solving toolkit with escalating actions to address different levels of uncertainty. We demonstrate the tools via a number of cases where we have employed these approaches, from long-term capital investment in resources to making career choices, to determining whether you risk outliving your savings, and to developing strategies comprising a portfolio of initiatives. Levels of uncertainty. There are many ways to understand and evaluate uncertainty, including statistical measures of variability and conditional probability. Previously, we lacked a way to describe and respond to different levels of uncertainty, without having to make spot predictions that could dangerously underestimate the range of uncertainty. Several of our former McKinsey colleagues addressed this need with a 5-level schema for assessing uncertainty. They brought new language into play in tailoring actions to uncertainty, such as big bets and no regrets moves that are now in widespread use. In this model, uncertainty levels range from level 1, what is a reasonably predictable future, to level 5, the unknown unknowns. Level 1 uncertainty, such as simple predictions and short-term forecasts, is discussed in earlier chapters and can be addressed with good team processes. More challenging settings are where the level of uncertainty rises to levels 2, 3, and 4. Level 2 are situations in which there are alternative futures that could follow from a legislative change or technology change, where the results will be binary in the sense of who wins/loses. The Brexit decision in the UK is an example. Another is how should auto insurers prepare for driverless cars on the road, where the time frame for adoption is uncertain, and the role of car makers in providing the insurance is unclear. Both of these examples are likely to have uncertainty resolved in a 5 to 10 year time period. Level 3 is where there is a range of futures that are possible, but where it isn't clear which one is more likely. Where fossil fuels fit in the energy mix in 15 years is an example. Scenarios range from similar to today all the way to a very diminished role. Another frequently discussed topic is what jobs will we have in the future with advances in artificial intelligence/machine learning and robotics. This will be clearer in a 10 to 20 year time frame. Level 4 describes true ambiguity, where it is not possible to conceive of all the potential outcomes or to predict them with confidence. You could put the issue of sea levels in Manhattan in 2050 into that category, although some climate scientists will have different views. In an update of Strategy Under Uncertainty, author Hugh Courtney gave the example of early-stage biotech investments having level 4 uncertainty. Level 5 is the nearly absolute uncertainty of events that are unpredictable with current knowledge and technology, sometimes called unknown unknowns. Uncertainty levels 1 through 4 are colorfully called the known unknowns, in contrast to level 5. We don't put them in a too hard basket. Instead, we approach them recognizing and quantifying the level and type of uncertainty.